we're late today. We're starting on our schedule of three o'clock, but this is new for us. We're doing some new stuff, and I'm super excited. We have team members here. We have build day going on as we get back into streaming after a break, and I'm gonna serve as the host and kind of like the tech leader for the day, as the founder of the Lift and Shift Foundation. But we want to change the way we've been battling our robots. And we behind the scenes last month we started working on some projects. So we're gonna excuse me. We're gonna share a little bit of that probably for the next 45 minutes. We're gonna live build a new layout for our arena. We're going to get into adding some of these parts and trying out some of the brackets that we made to kind of hack our robots. And while we're discussing that, I'm just going to share. Here it is. Here's our favorite robot. We've done some editing to him, positioned a few of the sensors, but this is a MakeBlock Ranger tank. And I dig it. I love it. So I'm going to kind of like recap a little bit about the program here while we're doing this. You can go to our webpage, sign up if you want to join us, drop a link, drop a request in the chat. We can share a link with you to get in here and actually battle with us. We're also looking for teams to battle us on this new arena. So let me do a little explanation. I'm going to do a little bit of an explanation. We battle these robots in an arena, basically, that I put together in my apartment, and we do this all remotely. So there's a lot of fun in the fact that we are not remote controlling these robots. We are actually coding the robots to battle, and we're coding the robots to do stuff without like real code. We snap together blocks in a website, and I collect the code and I upload it into the robots, and then the robots go. So we do this online, and we can do this across the country. The team members that we have here in the stream are all over the country, and I think almost everybody's a veteran, but it's not exclusive to veterans. Our design team works on Battle of the Bots as a program, but that also includes this online component that can reach anybody anywhere. We do this based in New York City in person, and I'm only one dude, so I can't be everywhere at once. But as the program, the live program grows, it only makes sense to start doing this online and sharing, some highlights and things like that. And at the end, at 4 p.m. at the top of the hour, wherever you are, I'll play a little video from highlights from the last few years of running the program live here in person in New York City. But I don't want to spend forever talking. I want to build stuff. I want to do stuff. So let's check it out. Let's check out the actual arena. Oh, I guess I have to change that. Okay, this is a little new for me today. But what we'll do is we'll unpin me. There we go. So that is the arena. Dun da da. And you can see one robot there. That's super cool. So we have this line. We have this. In fact, I can zoom in. There he is. There's our lift and shift bot today, and you can see there's this black line that basically runs across a big piece of poster board, and we've got a background set up so that it's not my apartment. But that's kind of like the confines of the arena, and what the robots do is the robots battle on this line. The goal has always been a sumo battle where they push each other off the line. And I'm gonna come over. I'm gonna move my mic, and I'm gonna come over and do a little chatting about the robot here. So as I get a little louder and come over and talk about the robot here. So the robot has an ultrasonic sensor and a line sensor right here, which actually detects dark and light colors, so we can tell if we're on the line or off the line. And the ultrasonic sensor we use to tell if we're in front of an opponent or not. and we basically start at opposite ends with both robots, and we let them go. And this is how we code the robots to push each other off the line. Well, there's some cool things that come out of that, and there's some highlights that you can see from older events where our code doesn't do what we think it does, or what we want it to do. Oh my gosh, my camera is just took a dive. Not planned. No. Okay, so my mic and my camera have just decided they don't want to be on the table anymore. Give me 1 second while I put that back. Super awkward. And solved. I wouldn't call that a recovery, but we're kind of back here for the moment. Oh my gosh. Okay, so now I can switch my views and come back to talk to you. Hey, hi, how you doing? Okay, I don't like being on the big screen, but so what happens here? As I'm mashing all kinds of other computers to get things to go. 1 second. Dun dun dun. Cool. Okay. Just opening my MacBook is updating and doing things. But so when the robots battle and when the robots do stuff, we have this ultrasonic sensor that finds the opponent, and this sensor here that will find the line underneath of it, or the dark place. A lot of times, what we see happening is the robots go off the line and they don't know it. Or the matches are actually very, very short is another problem that we have. Sometimes they just like knock each other right off of it, and it's a 5-second match, and it's cool, it's fun, but we kind of want matches to build in skill levels and build in more entertainment value for us as this goes on for like an hour. We spend a lot of time coding, and there's some value in watching the robots battle and actually being able to rotate teams through the battle. So what we want to do is we want to change our line, and we want to make it a circle, an actual like sumo circle, and we will do this so we will replace the actual poster board. Poster board is the word I was looking for. So we're going to replace that poster board with the black electrical tape. And what I'm going to do today is actually set up a couple different circles. I have paper that we're going to cut into a couple circles, and we're gonna spray my favorite. I have this can of Plastidip. It's basically liquid rubber, so it will spray the same rubber that we have been using. Which is electrical tape. The electrical tape is basically rubber with an adhesive on it. So I'm going to spray a couple pieces of paper, and we're going to make a circle that I can pick up and I can take away. And this is going to be very cool for our robot events here on Twitch and streaming and online type stuff. But I have a requirement that I want this to go with me to the in-person events. So when we do this here in New York City, we'll use the same materials that we use online, and that'll be cool for all everybody around. So very, very quickly, you can see up here on my desk, I have the desk camera set up and an arena camera set up. So we're gonna drop things in right now, and we're gonna try this part of it out. What we're gonna do is we've got some paper. we're literally just going to cut a circle. In fact, let me grab some scissors real quick. They're behind my little screen. All right, back with some scissors. Scissors right there. So to cut a circle, I'm going to do this the easy way. I'm going to fold this in half. And before I cut this circle, we should probably talk about the size of this. And you can chime in too, dude. I'm thinking we don't want a really big size for this circle. I'm actually thinking maybe like 5 or 6 inches, something roughly that big, because the robots are going to have these 2 sensors right here, and we're going to be trying to push them off. If we give them too much space, they may wander and actually not fight as much as we want them to. So I think our initial robot battle will probably be smaller circles as we try this out, and maybe we experiment with a few different circles. So I think what I'll do today is actually make a small circle about 6 inches. So I have the grid here on the table. Let's switch to view number 2. Right there. Okay, cool. So I have the grid on the table here, so we can kind of see 6 inches. 6 inches is 1, 2, 3, 4, 5, 6 right there. So from this line to this line, easy. So I'm just gonna snip right there. Then we can snip right about here. And I'm just gonna cut it right out. Easy. Cool. It's not a perfect circle, but it's close. So I'm going to use this. I'm not going to use this. What we're going to do is I'm going to make this a stencil. Like that. And we're going to spray it on this sheet of paper. So I'm going to take this over to the mat. And we're actually going to spray this up right now. And while it's drying, we will come back and talk about some of the sensors and things we have to do and change to make this work, because we had one sensor for distance to tell if the robots were on the lines, and our robots never veered away from each other. So we'll have to chat through some of the new challenges that come from moving from a line to a circle as we do this. So I've got a backer and my stencil and everything else. I'm gonna drag all this stuff over to the arena. I'm gonna unpin me. Poof. Oh wow, that works pretty cool. I dig that. So let's make the stream big. There we go. Turn my camera. And or turn my mic. Hopefully things don't go crashing again. Cool. Do I? Hi there. All right. So back here in camera view. Dun, dun, dun. We're gonna move our robot out of the way. I'm just gonna set this down so we can spray. And I mentioned we have this piece of paper here. I'm just going to shake this out for a minute while we do this. And the goal here is that this standard sheet of paper will now be on the center of our mat. So I'm going to spray this out. Let's see. Just like that. We're going to do a couple of coats. Yes, there we go. Overspray is a little crazy on this can. As I take this away, you can see quite a bit of overspray. which is why I grabbed the big sheet. Yeah, the overspray is obnoxious from this can, but cool. And you can see that this is clear, a clear line there. We're gonna let that dry for a minute. It should take probably about 5 minutes. My apartment's a little warm today, so we'll let that go. We'll set that there. They're not our sponsor, so we're not gonna talk too much about them. But let me come back to the table here. As I'm busting up my camera and everything else. Again. Cool. Excellent. So now let's come back to chat as I pin me. There we go. What are we gonna do now? Okay, so we're waiting for the plastic to dry. We're waiting for the spray to dry. It's gonna dry into basically a thin sheet of rubber attached to the paper, and I think that's gonna be our center piece for the arena. That's super cool for me. I dig that. That's super easy because it's a sheet of paper. I can carry it with me. I can take it to an event when we do this in person, and I can just set it down here in the middle of the line. So it can actually cover the line, and I think that'll work. But we'll talk about that in a minute. What we need to talk about now is where we have a circle. So the robots can technically move around a lot, right? Instead of going straight on a line back and forth at you, they can turn like this, and that's going to create a problem because they're not always going to see themselves. They're not always going to see, their opponent. They're not going to know where their opponent is. So we have a problem with this sensor right here, which is the ultrasonic sensor. So I thought I would grab a smaller robot and have this chat about the robot sensors. So this is the robot we use when we do this in person, is the M-Bot. The M-Bot is much smaller, and it has this kind of like standard metal frame that you can't really do much hacking with, you can't really do much to. And it's you can see right here, just 2 motors and a little roller. So it's very small. It's like fits in my hand compared to the Ranger, which is much bigger, almost 3 times the size, and much heavier too. But this sensor actually has, let's see, can I zoom in on this? I'm going to switch to the desk view right here. So on the desk view, you can see there's a T and an R on this sensor. This is a transmit, and this is a receive. So what happens here is this works just like a bat. So it sends a signal out at you like that, and it bounces off your screen or your camera, and this receiver receives the sound, and it's a sound that we can't hear, but kind of like a dog whistle, like dogs can hear sounds, and bats can send a signal, a sound. They can chirp in a way that we can't hear. This is how bats do their thing. Dogs can't use it like bats, but they can hear things that we can't. So this will send a signal out, and the time it takes for it to transmit to receive, you can do some math and figure out how far away the camera is. But this only works in one direction, right in front of you. And in fact, there's a small cone where this comes out. It's about 15 degrees on each side, is what we've determined for our team here. So what we realize is we need more than one sensor. And last month we started designing these parts right here, this bracket, so that we can hold 2 sensors on the robot. And then we'll have vision like a person, we'll be able to see a bigger field of view and detect objects in a different way. And I'm realizing now that this actually would make a really cool Thursday night like tech stream. We could set up a screen so that we could show this, the obstacles. I'm digging that. But what I'm going to do is I'm actually going to rob the sensor from here, and we're going to add it to our Ranger right now while we're waiting for stuff to dry. So I'm going to grab my fancy tool that comes with the tank and the M-Bot, and it's got a little plus type Phillips attachment on one end and a hex on this end. So we're gonna remove, because we're gonna steal the sensor off of this robot here, and we're gonna add it to our tank. Yeah. There we go. So I want the sensor the cable and everything. There we go. Okay, so that's the cable. Let's take the cable and all. That's it. That's that right there. And I don't know if anybody is old enough to remember, but this is actually, what is it, an RJ45? It's from a telephone, the old school telephones that you plug into the wall. And that's the way they transmit the signal back and forth from the sensor to the brain of this robot right here. So the brain of this robot right here is has all these ports and plugs on it, and this is how the sensor gets to it. But we're gonna let's put these screws back on our M-Bot, just so I don't lose them. Just a quick thread them back on there, and we're gonna put our guy back in the box that comes out of, so I don't bust things up and get things all crazy. And we can put him aside. Oh, the box is not closing for me, which makes things awkward when I try to put it away. Let's grab our tank. Let's grab our Ranger now. You see it's a much bigger setup already, right? So we've got this part here, which is already here, and I'm going to try to fasten these sensors right to it. So let's try this. I've got a box of extra parts here, so we can try this a bunch of different ways. Let's actually see if this fits right here, like that. That seems to line up. Oh, the holes are a little off. Oh, and very, very tight fit. Oh wow, we could actually just not use the nuts on the back, and this threads right in to the hole. Super cool. Although we want the nut on the back for a little extra stability. I'm realizing now that I can't see the screen, so I don't know if you are getting... Okay, cool. It looks like you're getting all of this, at least. So we're going to build out our robot a bit and add the sensors. I think I want this sensor on this side, though. Oh, it doesn't really matter, though. So let's see. First, will these line up like that? Oh no! That's too far over. We will have to move this one step over. I need to take the nut off the back. There's not enough space on this bracket to use this hole right here, if you see that, because this hole right here needs to be there. So we should probably put the, if we tried to do this on the center hole right there, it would we would need this one on the center also, so that there's enough space right here, because otherwise this one takes up everything. So we'll use the center holes on this. So let's slide this over one. Dun, dun, dun. And cool. That is very cool that it basically just threads right in there. Okay, so yes, that lines up well for us right there. Both sensors fit on this bracket. Cool. Very cool. So let me grab a couple extra screws. I've got a box here full of parts. My extra parts box. So we're just going to grab, I'm going to dump a bunch of screws out. Varying lengths. I don't think we need long screws here for the outer edge. We're going to set another screw in the middle here. These are actually technically bolts, but I'm not gonna be a big stickler on words and terms. Screws have a point on the end. Bolts have a don't have a point on the end. I'm sure that there's something more technical to it than that, but that's just my little pea brain. All right. Cool, and we can add the screws, the nuts to the back, but I want to set this and seat this now. So I'm going to disconnect this part and reroute that in a minute. But we want to place this here. So I'm going to remove this other bracket that's already there. Dun, dun, dun. And see that we need a longer bolt. So we're actually going to take this bolt. Cool. And we will fasten this bolt to our bracket. And now we've got a hacked Ranger tank with 2 distance sensors. And we will drop this down just like that. I think the challenge here will be putting the screws in while sharing the view. So we have some options here. We can try to lower this down as far as we can go like that. That looks a little crazy, right? And dude, we talked about this before. I think we measured this in a workshop where we said that these eyes won't catch this tread. I think we shared that or showed that, but I still feel like I want to put this up a little higher like that, just in case.
We're talking about lower because of protecting the sensors between the treads.
Yeah. That's I completely want to protect it in here so that the sensors are protected by the treads when they're battling. So we may have to extend this out a little bit, maybe make this taller so that they come out further. But if you look at it, this is recessed pretty far back on that angle. I'm my curiosity is wondering, like, is this going to catch the tread and not reflect back? So we may have to run some tests. That might be something I do on a stream on a different day. So I think the challenge is going to be getting this nut held in there. So what I will do is I will disconnect all of these parts first. I will move my big meaty claws out of the way. Like that. So we will loosen that up so that I can get this part in here. Okay. Very close. But I need to crank this down all the way so we can get the parts touching. That'll be the challenging part. Right there. Okay, cool. So that is all the way threaded through. We can now attempt to line this up. I might have to actually take this bracket. Yeah, we'll take the bracket all the way off instead of trying to struggle with this. There we go. Cool. There. Easy. Excellent, excellent, excellent. I dig that. I could probably grab a couple extra nuts there and fasten these on. Yep, we will do that. I've got plenty of them right here. There. And I will send the rest of the parts back to the box. One nut on fastener, two nut on fastener. I will hold these with my fingers while I just give it a little torque just so that the nuts have grabbed the back of the material, the back of this 3D printed object. We actually designed this and 3D printed this. I can share that later. So we need to route this plug over here so that it will reach our sensor. Now we can set our sensor back, our bracket back with these other parts just like that, which we've also kind of like aligned. In a previous workshop. So this robot is not the way that is not no longer set up the way that they do at MakeBlock, and that's cool. It's kind of like we're hacking it, making it our own, and I dig that. I think that's cool. And as we find new teammates and new teams to battle with our robots, it's going to be cool to see if anybody wants to take on projects of designing more parts, because we've done quite a bit of hacking on this robot ourselves. And I will be happy to explain all of the hacking that we've done. In a minute. So that is not lining up right there. There we go. Very cool. So now our Ranger tank kind of looks like a spider. It looks like it's got 4 eyes. When in reality it's got 2 eyes. So let's connect this plug here, port 8, and this is connected to port 10. So we will have to know that now when we're coding. We will have to set up a standard block of code that says these ports are set to a certain spot. We have not had to do that yet. So we'll have to know now in our code which eye we're talking about. And here's the final view right there. Check it out. Cool. So the eyes are recessed pretty far back, so they're protected by the treads when the robots go head to head. And this line sensor right here that we've also moved back very far. It's actually behind this bracket. It was sticking out much further. The way that hi. So the way that we've done this in the past, we followed the instructions to build this thing. This line sensor actually sticks out far in the instructions, and this one eye sensor is up very high. Yeah, in fact, if you check out the box here, you can see right here. I'm gonna get real close up in on you. You can see that the sensors actually are supposed to stick out by design for the MakeBlock team, and that's cool for the MakeBlock team. For us, we had the sensors get caught in the fighting and in the sumo matches. So we've moved the sensors. We moved this one back as far as we can. So it is back recessed about, if I set it down on the table where you can see this here, it's recessed about 1.5 inches back right now. So the treads are 1.5 inches in front of the line sensor. These are about 1 inch in front of the line sensor. That's gonna matter to us because we have this small little circle. This is gonna be looking for the circle. This will be looking for our opponent. This will be coming into contact with our opponent. So we need, the circle has to be a minimum of 3 inches. So we're basically giving our robots 3 inches extra inch, because the circle we just spray painted like 5-10 minutes ago is actually roughly between 6 and 8 inches, give or take, and that's if we take away an 1.5 inches on this side and 1.5 inches on the other side, that's 3 inches. So we're giving our robots basically 3 to 5 inches of space to shake and bake, roll, dive, stiff arm, whatever moves they got that they're going to put on their opponent. That's the space they have to do it with, and that's why I think a sheet of paper actually works pretty well for this as far as size is concerned. We might have more fun later making this larger, and especially if we add more robots to this, all of a sudden it gets very, very challenging. So the first step in this is creating these eyes. The other thing we did was we made a plate right here, so you can kind of see this plate right here. We 3D printed this plate to move the battery box, because the battery box originally was underneath the brains, this motherboard right here, and if you've ever seen the BattleBots, if you've ever done this here and on this arena, the batteries pop out all the time. So it really dragged down gameplay for us. And since we moved the battery box back and turned it sideways, battery swaps take five seconds instead of 5 minutes now. So these are all things that we've done to this to make it a tactical fighter instead of the STEM learning project for kids and adults and anybody as low as 8. So this works much better as an opponent on our mat now, and I'm excited to see what else we do with this next. But we should probably wander over and try this out and see if the sensor picks up the paper. So we will. I have the other robot over there. We're gonna set them down and set these both. We're not gonna build both robots today because we're gonna run out of time, and I think what we will do today is set both of these robots down, kind of like just so we see them on the paper and we get an idea of they fit, they'll work. Where should we start? Where should we stop? And feel free to throw in like that doesn't look good, or something I might not be seeing, because I'm gonna be like in their face over there. You'll be seeing it on the camera, so you'll have a different angle than I will, because the camera's like low down. I'm gonna be overhead, so I will definitely have a different view, and I'll appreciate any feedback on how that works, how it looks. But we're gonna go over now, check this out on the paper, and then we'll come back. I'll bring the robot back here, and we'll confirm that the line sensor actually works with the thing I just sprayed. So that's probably the rest of the stream today. That sounds like a reasonable plan. I'm actually kind of psyched that this all fits together. Very cool. And we have another one for another Ranger, so we can do this. I kind of want to clip this on. I think we need. We might need to find a way to clip these on, because that's a very long process of building these. If we were to do this in a stream, to take a 10-minute intermission for like bolting on parts is, I mean, it took us 15 minutes basically to do that, and that was just one robot. So that would take like a half hour. Probably between, if we were going to do like an easy mode on the line, and then an intermediate or a medium mode on the circle, we would probably have to have 4 robots, 2 set up like this and 2 set up like they were. So may have to reevaluate how this bracket works. But this being our first bracket, this looks good, and everything lined up perfect right here. Very, very, very tight fit. It does what it's supposed to do. I'm excited about it. I think it's cool. But we'll come up with something better. So let's unpin me from the screen. Rotate the mic around, and we'll go back to the mat over there, and we'll size this all up. We'll clean up my spray paint mess and see what happened. Maybe make sure I don't need another coat. I put it on pretty heavy, and it's been 15-20 minutes, so it should be dry by now. All right, I dig it. Unpin. Poof, there's our scene. Pow. No distractions over here while I turn this. Oh gosh. Okay. Now I'm terrified that my camera's going to just crash again. Here we go. We're back. Here's our robot. So let me just chuck this. We no longer need this. We'll set it over here. Get this out of the way. And check out our paper. The paper does have a solid circle on it. I see a little bit of hazing right there. Maybe I could have put a heavier coat on it. We'll check that out in a minute and confirm that before we get rid of everything else. I'm going to move my back spray right there. So this is what it would look like. We would set this paper down after we have our easy matches on the line, and we step up to a medium difficulty level. And I think, so here's the edge of the sensor right there, and here's the edge of the sensor right there. So I think that is a reasonable amount of space for them to try to push each other off out of the circle. I think that works.
Yeah, looks good on my angle.
All right, cool. I think that could happen. And I'm looking overhead here, and I'm seeing, like, it's possible if the robot is turned this way that he's not going to see an opponent here, and it's possible that the robot is here and may not see an opponent on this side. So using the sensors is looks like it'll work. And that's what we were concerned about as the circle happens. And maybe another take on this is making the circle wider that way, because my circle is kind of like an egg shape. So this is the 6-inch side. As we kind of line these up, right there even. And what I'm noticing now is the closer we get, the less chance there is of them not seeing an opponent on both sensors. So I'll be kind of curious to see how that works out for us. But like I said, the goal here is now that they want to try to like push each other off. So it's not just going back and forth on the line like we were doing, but it can involve like sweeping or any other kind of like motion that might push the robot off the edge here. And yeah, I'll be interested to see how we do this with code, because there's new options. But yeah, this looks good for this part, and I think having the space on the paper here means that the robot will know that it's gone off. It won't mistakenly go to the end here or onto the tape and think that it's still on. So I think that works. And even still, we could actually just set this over there if we wanted to, or bring it closer. How does this? Do you dig it more having it closer to you?
Yes.
All right. So possibly for the intermediate or medium skill level or difficulty level, we bring things closer and closer. And I may make a bigger circle still. I may make one that's like the full circle size sheet of paper. And we'll try that out. But let's leave the lift and shift bot here. Let's bring this stuff back to the table so we can test the sensor and actually look at it and see if it's doing what we want it to do. I think this is probably the last good test of what might happen. Oh my gosh, my camera, I figured it out. There's this little screw right here. Stopping things from happening. There. Cool. That's why it was so scary. Why it looked like it was gonna die. 1 second. Dun dun dun. And we are back. Poof. Ta-da. Okay. So now that you get a closer view of this, let's check it out. Actually, let's put it on the table. Let's do the table view here again. How's the table on your end? You can see this, right?
Yes.
Cool. All right. I don't know. Is it so? Quick question, since it's a group thing and we're trying out a Teams meeting as opposed to Zoom. So usually we do this on Zoom, and we get the design team and everybody to join us through a Zoom event, and then we stream Zoom onto Twitch is how this works. So when I share my screen on Zoom, it goes full screen for everybody, and I have frequently share buttons with reminders on to tell people how to get out of the full screen view in case they want to hop into a browser with me or something like that. But so I shared my table view with you in the Teams meeting. Did it go blow up full screen on you?
Yes, it does, but I have it in a smaller view.
Gotcha. Okay, cool. All right. I was just curious how that works on your end. 'Cause I've never seen somebody share screen on a team thing. Uh,
Once we get out of here, I can share screen with you and we can see.
cool. Yeah. Definitely. Okay, back to our thing here. So this is basically just rubber sprayed down, and I can feel it. It definitely feels like rubber. It feels like a electrical tape, like the kind of like friction related. And what we will do here is set our robot down. I don't know what code is in the robot, so we're gonna disconnect the motors just for a minute so we can play with the robot. And what we want to do is we want to see down here the sensor. So I'm going to plug the robot in. Robot is on. Ooh, that's a lot of light. Okay. That's an annoying amount of light. But what we're looking for is down there. Right here, there are some lights that you should be able to see, and I should be able to see when it detects a white space. So you can see those lights shine up when it goes off the circle. And that's what we want to make sure that this actually works. This works for the robot. I've tried a few different methods of creating things and obstacles and for these robots. So not everything works all the time. And one thing I've learned as I'm mashing other buttons here is to test this out, to try to confirm that it works, because I've used other kinds of tape before. One thing I've used is fabric tape, hockey tape. If you've ever had, play a sport, hockey or anything. Let's come back to the normal view. So, hockey tape. I have black hockey tape, and it does not work. And it's because the light, that little light that's shining down, does not reflect off of the fabric, the black fabric, like it does for the electrical tape. This electrical tape, it's shiny. It has a surface that reflects, where the fabric has a surface that is kind of like woven together, so the reflection doesn't come straight back up. The reflection kind of gets diffused and spread out everywhere else. So the robot never thinks it's on a black surface if we use black fabric tape, but if we use black electrical tape, it does work, and it does pick up the difference in color underneath of it. So this works. We just tested it. So this method of spraying that down, it works. It's good. What I might do for this is go get sheets of construction paper, like black construction paper, and I may just cut them into a circle that we can set down. I like the idea of using this because then we can shape it, and it's literally a piece of paper. I don't have to worry about it being on the mat. I don't have to worry about it interrupting the arena or any changes to the arena. So this is kind of what I like, what I like to see, and what I was hoping for. Everything worked out here just the way we thought, and we got a robot built. So when we
concern would be the paper itself when the robots are on.
yeah.
They
Yeah, that's I kind of want to make more, just to have backups, because I was thinking the same thing. As we do this, there's a good chance that the treads bust stuff up. Maybe they crunch up the paper or move it. Usually I tape everything down over there, because in the past the robots have pushed each other into the background and knocked things around. They almost knocked my lamp over one time. Yeah, no, it can get a bit rowdy when especially when the Ranger is off to the end. Is we've done a couple a couple of these where we program them to like go, and they go. In fact, once it knocked my phone over. Yeah, it gets wild and crazy. I'm always worried that they're gonna knock my my tablet over because my tablet is sharing the arena cam view. But yes, the paper is something I'm concerned about, and the space, the amount of space. So I think when we start the actual like streaming battles, we probably want to think about the space, and we might try different rounds with different sizes, so we can see if the sizes change the way our coding works. But yeah, dude, you are right to be worried about the paper. I feel like we'll need extra paper, just like we were talking about making extra face masks for the robot, because we smashed them up rather quickly, and I'm interested to see how long this piece of paper lasts. But we can build other stuff too. I will close the stream here by saying that this part that we've created, we've actually as a team designed this and built this in Tinkercad. So we have a shared workspace as a design team, and for those who don't know, Tinkercad has this feature where you can more than one person can be in the workspace at a time working on it. So we share a workspace, and I can actually yes, I have that open today. I can share that, I think. There it is right there. So there's our workspace right there. You can see this part is green. I'm going to zoom in on it. This part is right there and it's green. And you can see it right here in my hand. That's this right here. We printed this. This is printed in PETG material because that's what I had on my little printer at the time, and I printed it with this lip around the outside that I should trim off. Basically, that's it. So we can work on some other stuff. You can see some of the other parts that we made for this robot in there. If I were to scroll, you can probably find the plate that we designed. Yeah, there's the plate, our battery relocation plate. You can see we've actually modeled this sensor in Tinkercad, the eyes, so that we could work with it in a digital space. There's a bunch of other stuff in here that we've been working on, like face masks and things. And just a reminder that for our design team, if you want to make stuff in here or in your own workspace, we have these two motors right here. In fact, I'm looking at them right now. We have 2 bags of these motors that are actually here in Tinkercad. So if you want to make anything that moves or goes in Tinkercad, we can print it for you, and we can and by you I mean our design team, but team members of our design team can this is part of our virtual workspace or our virtual maker space where we can do cool stuff and build cool stuff like motors and brackets and all kinds of other stuff. But this is something we designed, and this was pretty simple. This was easy to line up, and it works out great. I'm gonna spend some time thinking about maybe how we would change this so that it's a clip that attaches to maybe that bar on the top, or somehow maybe lines up the screws differently so that the screws slip in and out somehow. I don't know. I'll have to put some thought into that, but we'll probably come back and redesign this at some point and print a new version of it. But for now, this works. It works cool, and that's my concern about the gameplay, and having this be fun for everybody when we actually like stream battles. Is I don't want everybody to sit and wait, for 10 or 15 minutes while I'm busy, assembling and disassembling robots. So this is cool, and this works, but we will find a way to speed that process up, so that we're not just using the using our time to watch me with a screwdriver. Yeah, but that's about it. So I can chuck my cutout now. Actually, I'll save that for recycling. I can that was rubber that I sprayed, so I think I can recycle the stencil that I used. I think we're done. I think that's about it. And I just noticed we hit the 1 hour mark of streaming, which is never really I'm not like a big Twitch person, so I don't really know like how cool it is to stream for 24 hours or whatever else other people do. We're kind of here to reach a larger community and share the things that we can share, as part of the program to help other people who maybe can't do this in person and can't find a way to, even if they're near me, get out, whether it's childcare, whether it's transportation, whether there are other issues that like mobility challenges, anything that might stop somebody from doing this in person, was really my goal to bring this online and do this for people as a service from the nonprofit. It only makes sense to do this on Twitch. We're not here all the time, and we're not here to kind of like rub our noses in whatever anybody else is doing or be cool about it. We want people to play. We want people to have fun. That's the end of my speech. I'm going to play a little video. So if anybody catches this later, you can go back and look at the in-person events here. So I'll play it. I call it a highlight reel, but it's kind of like a thank you video. And I think I spelled the Wounded Warrior Project wrong. But we'll just play the video anyway. And I appreciate the time on the stream. Also, our design team here. It's always cool to have some feedback. I'm gonna play that now. Ready?
You know what I mean? Like, walk for this side. Mark, get set, go. Point for this these guys.
Let's go. Have at it. Oh. Oh, and they're struggling. But they're not giving up. It's still a fight. It's still a fight. It's still a fight. What are they? There he is.
No, yeah. Oh,
He's-
who got it? Who got it?
Best 2 out of 3.
3, 2, 1.
Go. Go. Have at it. Oh! 2 batteries down. I think that might be a draw.
Yeah, I'm gonna call that one a draw.
That was hysterical.